All right, now we're going to take a look at multiplying and dividing fractions. This is really quite similar to what we did in the last section. We're going to use the same skills. It really mostly boils down to factoring, and then just sort of being careful. You know, the devil's in the details with these problems. We already are familiar with these rules. We looked at multiplying and dividing expressions back in Chapter 2. So we know that if I'm finding a product, I just multiply straight across, right? Put that product up top, multiply straight across the bottom, put that product on the bottom. I know that if I'm dividing, the first thing I'm going to do is flip the second one over, right? We change it into a multiplication problem, right? The first fraction is the same. We flip the second one over. Dividing by a fraction is the same as multiplying by its reciprocal, and then we've turned it into a multiplication problem. We always want to factor first. In the first example, in 613 here, there's no factoring to do, right? Everything is really written as a product. So all that's left, all that we need to do is cancel common factors. So, you know, how many steps you kind of include in this problem probably is up to you a little bit, but I'm going to just try to be really clear about how I'm getting my results here. So 15b squared, that's 5 times 3 times b times b. On the bottom, of course, is just a. So now, look, we can cancel. A cancels with a, 5 cancels with 5, a b cancels with a b, and we are left with 3 times 3 is 9, b. All right, so that's as far as we go there. This next one, we do have a little bit of factoring to do. Some of the factoring's already done for us, right? Like in the first fraction, everything's factored. But in the second fraction, we have some factoring to do. So I've got 3 times x minus y. And the bottom, x minus y squared. I'm actually just going to write that as x minus y times x minus y. You could leave it written as x minus y squared if you want, but I find it helpful to write it out like that. In the second fraction, in the top we have a difference of squares, so we've got x minus y times x plus y. This is over, let's see, now in the bottom we have a common factor. We can take out a 3. And then we're left with 2x plus 3y. Now that everything's factored, I'm going to whip into a frenzy of canceling. This is the fun part. X minus y with x minus y. X minus y with x minus y. 3 cancels with 3. And what we're left with on top is x plus y. What we're left with on the bottom is 2x plus 3y. These, the top and the bottom, have no factors in common, so we cannot go any further. All right, let's try another one. This is another product. Again, I'm going to start by factoring. Factor everything. So in the first fraction, I could take a 2 out of the top. We got 2 times x minus 2. In the bottom, I could take out a 4. 4 times x plus 3. Times, in the next fraction, the bottom, 3x minus 1, that's already factored. We'd say that is irreducible, so I'm just going to leave that as 3x minus 1. Up top, that's a trinomial. I think we can unfoil that. To get a 2x squared, we need a 2x and an x. And then a minus 15. So I need a plus and a minus, either 15 and 1 or 3 and 5. And the middle terms have to come out to a plus x. Maybe you want to pause and see if you can work out the factoring before I tell you what I got. I get 2x minus 5 and x plus 3. And you could do a quick check here. This gives us minus 5x, and this gives us plus 6x, which combine to give us the plus x over there. Now that everything is factored, we're going to cancel what we'll cancel. 2 goes into 4 twice and leaves us, we cancel one factor of 2 and leaves us with a factor of 2 there. x plus 3 cancels with x plus 3. I think that is everything that will cancel. So up top we have x minus 2 times 2x minus 5. On the bottom, we have 2 times 3x minus 1. Okay, let's do some division problems. You know, the first step in doing a division problem is just to rewrite it as a multiplication problem. I usually do that first, even before I start doing any factoring. So in the first one here, there's no factoring to do, because there's no addition or subtraction, right? Everything is just written as a product. So we have 3a squared over 5c times, and then I'm going to flip the second fraction over, a over 2c squared. In this case, nothing cancels, right? So we're just going to retain all of our factors. When we multiply, we get 3a cubed over 10c cubed. Next, I think there is some factoring to do here. Before I do any factoring, I'm just going to rewrite it as a product. X plus y over 3 times 6x plus 15y over 2x plus 2y. You know, sometimes some people like to flip the fraction, you know, turn it into multiplication and do the factoring at the same time. But I find that if I try to do both of those at once, I end up making some kind of mistake. So I've really learned that personally I need to tease out, separate those two steps. So I've written it as a product here. I'm going to do some factoring. The first fraction, there's no factoring to do. In the second fraction, up top, I could take out a 3, and we're left with 2x plus 5y. In the bottom, we could take out a 2, and we're left with x plus y. And now is the fun part. We whip into a frenzy of canceling x plus y with x plus y, 3 with 3, and we are left with 2x plus 5y over 2. Now, there's no common factors here. All right, so as written as a single fraction, that's as far as we can go. If you want to go further, in this case, you could, in that, you know, I've got this fraction, there's only a single term in the denominator, so I could split up this fraction and write it as 2x over 2 plus 5y over 2. And now, just in that first fraction, we can cancel those 2's if we like, because that is, you know, we're not canceling over addition. That is a common factor of 2 now. And we get x plus 5y over 2. And really, either of these is fine. I usually will just leave things as a single fraction, but either form is okay. Notice what we can't do is that we cannot, I'm going to make some marks here that I'm going to erase because it's incorrect, but we are not allowed to do that. That does not work. We can't because of that addition. We cannot cancel over addition. All right, let's do one more. This is a division problem, so I'm going to start by writing it as a multiplication problem. Flipping over the second fraction, so we're multiplying by x squared minus 9 over x plus 2. Now I'm going to just factor everything that I can. Up top here, in the first fraction, that's a difference of squares. 2 plus x times 2 minus x. In the bottom, we can unfoil that, and that's x minus 2, x minus 1. In the second fraction, we have another difference of squares up top, so that's x plus 3, x minus 3. In the bottom, we've got x plus 2. Now, we could do some canceling. I mean, right off, maybe you can already see that we can cancel x plus 2 and 2 plus x. x plus 2 is equal to 2 plus x, right? They are just exactly the same factor. You can rearrange the order of addition without changing what it's equal to. Now, though, you might also be wondering about this 2 minus x and x minus 2. If you think back to what we did in the last section near the end, they're not the same, but I can kind of make them the same. I'm going to factor out a negative 1 from the top here. So that's a negative, parentheses, x minus 2, close parentheses. And then everything else I'm just going to write as is. Of course, in the bottom of the second fraction, that's just a 1 now. I've canceled everything, the only factor that was there. And now we can cancel the x minus 2's. So what we're left with is minus x plus 3, x minus 3 over x minus 1. And you can leave it like that. If you are inclined and you want to multiply out that product and call that x squared minus 9, that's okay to do. It's usually, I think of it as just an extra step that is unnecessary, and I kind of like seeing things factored, so I leave it like this.